Let's actually start section 8.1 for real. Section 8.1 is called Gaussian elimination. And definition here. Oops. Gaussian elimination is a systematic technique that starts with elimination until one variable is solved for. Then switches to substitution to find the remaining variables. So it's a combination. And it's very systematic. So we're going to look at an example of that. We're going to up the dose. Let's take a look at an example here. This is the system 2x plus y minus 3z equals negative 8. X plus 2y plus z is equal to 1, and negative x plus y minus 4z is equal to negative 7. So this is 3 equations in 3 unknowns, x, y, and z. So we have 3 variables now. And I watch students go through this section and sort of have a fundamental understanding of everything that we just talked about. But for some reason, they really start to chase their tail and go in circles here. And you got to really go slow here and make sure you're doing things in a systematic way. Otherwise, you're going to get frustrated fast, and then you're really going to give up on this section. Well, maybe not you specifically, but I see it a lot with students. So this we need to talk about the rules for Gaussian elimination. I did not spell elimination correctly up here. I thought that looked weird. There we go, Gaussian elimination. Okay, so we're going to talk about what are called EROs. These are elementary row operations. So when we talk about a row, we're talking about an equation. These are operations that you can do to rearrange what a system looks like that will make it easier to solve, but doesn't change what the answers to the system are going to be. So here's the idea. Number 1, ERO number 1. We can permute or switch any 2 rows, and it will not change the result. So what I mean here is, when you look at this system of equations here, and you have 3 equations, equation 1 and equation 2 and equation 3, it doesn't matter what order they appear in. It doesn't matter that equation 1 was listed first or last. That is to say, x plus 2y plus z equals 1. Negative x plus y minus 4z equals negative 7. And 2x plus y minus 3z equals negative 8. is the same system and will have the same solution set. So rearranging the order in which these appear isn't going to change anything. Now, we have notation for that. ERO notation. When we start off with, let me just cut and paste this here. Duplicate. And let me cut and paste this one as well. So as we move from format to format, and this is equation 1, equation 2, equation 3, what we do is we use really simple notation here. So what I've done is I've taken equation 3 and made it my new equation 1. I've taken equation, oh, sorry, I've taken equation 2 and made it my new equation 1. I've taken equation 3 and made it my new equation 2. We've taken equation 3, and my tablet is being ridiculous. I've taken equation 3 and made it into my new equation 2. And then, of course, I've taken equation 1 and made it my new equation 3. So that's how we annotate that, with this notation on the end here. These are the EROs that we've performed. Okay. The second thing that you're allowed to do, let's see, ERO number 2. You can multiply any equation by a non-zero value. So what's going on here? You know, if you take a look at something like x plus 2y equals 3, and you multiply by 7, you get 7x plus 14y equals 21. So it looks different, but whatever was the solution here, you'll notice the ordered pair 1, 1 was a solution, is a solution to x plus 2y equals 3, because 1 plus 2 times 1 equals 3. But 7 times 1 plus 14 times 1 is also equal to 21. This is also a solution to this equation. So scaling it up or scaling it down by a certain factor doesn't change whether or not a certain ordered pair is a solution, as long as you scale every term up or down by the same amount. Now, I say non-zero factor, but must be non-zero. But the scaling factor must be non-zero, because if I take x plus 2y is equal to 3, and we note 1, 7 is not a solution because 1 plus 2 times 7 does not equal 3. If we multiply this by 0, x plus 2y equals 3, we get 0x plus 0y equals 0. And then 1 comma 7 is 0 times 1 plus 0 times 7 equals 0 becomes a solution. But this is not related to the original equation. So watch out. You can multiply by anything you want that's non-zero. So that's where we're going to start using the elimination. So if I take this stuff here, duplicate, clean this up a little bit. So this is my, let me annotate this. When we do this, these are my new equations. So this is my new E1. This is my new E2. This is my new E3. Even though those weren't originally E1, E2, and E3 when I was originally given the format here, in this next iteration, these are my new equations. So then what I can do, sort of ignore this stuff. That was the last set of EROs. Whoops, come on. I can get a new system here. So I'm going to start to do some elimination. So I might do something like the following. Twice E1 is my new E1. So look at that notation. What that says is we're going to replace E1 with 2 times E1. So that'll be 2x plus 4y plus 2z is equal to 2. So that was, let's see, that was this row. And now that corresponds to this new row, or new equation 1. It's twice as much. I'm going to do the same thing in the next row. I'm going to take 2 times equation 2 and make it my new equation 2. And this replaces equation 2 with 2 times equation 2. And that's going to give me negative 2x plus 2y minus 8z is equal to negative 14. And then I'm not going to do anything with the bottom row. 2x plus y minus 3z is equal to negative 8. Now I did that. Oops, I'm going to highlight this here. So these were the rows that I was changing. And these are the EROs that I used to change those rows. And this one I left alone. Or if you like, E3 is my new E3, and I didn't do anything to it. Now, what that has done for me is, or actually, you know what? Let me go back here and do this. I'm going to do negative 2 times that row, so that this will become, let me change all my signs here. This will be a positive 2x, a negative 2y, a positive 8z, and a positive 14. Sorry about that. Second guessing myself. Now, the idea is this. This first column of x's now all have, oops, the same quantity of x's. So that's an example of the second ERO that we can use. ERO number 3. We are allowed to add or subtract any two rows to create a new row. So let's see here. If we have something like 2x plus y equals 3 and 7x minus 4y equals 3, we'll note that 1 is a solution for both rows, right? 2 times 1 plus 1 is equal to 3, and 7 times 1 minus 4 times 1 is equal to 3. No big deal. And if we add these two together, we get 9x minus 3y is equal to 6. But 1 is still a solution because 9 minus 3 is still equal to 6. So adding or subtracting any two rows together to create a new row, so this is mine. So if this was equation 1 and this was equation 2, this is equation 1 plus equation 2, and it still has the same solution. So what we're trying to do is we're trying to rearrange some of these rows and create new rows that preserve what the solution set is going to be. Now, why is that important? Well, now we can start eliminating some rows. So let me take this guy, duplicate him, erase some of this colorful stuff here, and we're going to create some new rows. I'm actually going to leave this first row the same. 2x plus 4y plus 2z is equal to 2. And now I'm going to take row 1 minus, not row 1, I'm talking about equations here. Sorry, I'm using the other notation. Equation 1 minus equation 2, and I'm going to make that my new equation 2. So equation 1 is 2x plus 4y plus 2z is equal to 2. Equation 2 is 2x minus 2y plus 8z is equal to 14, and I'm going to subtract. So this is equation 1 minus equation 2 is my new equation 2, and that's going to be 2x minus 2x is 0x. 4y minus, don't forget that you need to distribute these here. That's a common mistake. This is going to be 0x. 4y plus 2 more y is going to be plus 6y. 2z minus 8z is negative 6z. And 2 minus 14 is negative 12. And so that's going to go right here. 0x plus 6y minus 6z is equal to negative 12. In fact, sometimes we don't even write that 0x, we just leave it off. The next elementary row operation I'm going to do is very similar. I'm going to do equation number 1 minus equation 3 and make that my new equation 3. So that's going to look like this. 2x plus 4y plus 2z is equal to 2. That's equation 1. Equation 3 is 2x plus y minus 3z is equal to negative 8. That's equation number 3. And we're going to subtract. And that's going to give me my new equation 3. 2x minus 2x is 0x. 4y minus y is 3y. And 2z minus negative 3z is 5z. And 2 minus negative 8 is 10. So my new row 3 is 0x plus 3y plus 5z is equal to 10. Now, let me pull this down here. Duplicate. What we want to note here is we have now eliminated x from equation 2 and equation 3. That is, quite separately, 6x minus 6z is equal to negative 12, and 3y plus 5z is equal to 10. So now this is a system of 2 equations and 2 unknowns if we just look at the bottom 2 rows. So we went from 3 equations and 3 unknowns to this bottom 2 rows, which only contain 2 variables. So we're hot on the trail of solving this, but we got to go just a little bit further. So let's clean this up. I am going to simplify this again. This is x plus 2y plus z is equal to 1. What elementary row operation did I just use? Can anybody tell me? Is anybody alive out there?
You took out a 2 from the equation?
Yeah, so I took, let's see here, let me get a different color. I took row 1 and I factored out a 2, or what I did was I took 1/2 of equation 1 and I made it my new equation 1. And I'm going to leave off those 0x's. I'm going to write this as y minus z is equal to negative 2, and 3y plus 5z is equal to 10. So what I've done now is, what color have I not used yet? Blue. So for this new equation 2, I didn't write the 0x. There's no x's there, but I took 1/6 of equation 2 and made it my new equation 2. Or as you say, right, like I factored out a 6 just to simplify that so I didn't have super large numbers I had to deal with. And then equation 3 is still my same equation 3. I just didn't write it with the 0x in there. So there's no operations done there. So those are the EROs that I used. Now what I'm going to do is move down to my second row. So I've already done everything I can with this first row. I use this first position to zero out all the rows below it. We're going to talk more about terminology for that. That's actually called what's called a pivot position. So we use that first pivot position to clear out all the other variables underneath it. Now that we've cleared out this row, now that those are all zeros, we're going to move to our next non-zero position in the second row. So this is our new pivot, and we're going to clear out the variables underneath that. So the next row operation I'm going to do is the following. Let's see, I'll leave the first row alone. That's x plus 2y plus z is equal to 1. This is y minus z is equal to negative 2. And this is what I'm going to do. I want to eliminate, we want to eliminate this y variable in equation number 3. So how are we going to do that using equation 2? Well, what I'm going to do is I'm going to take 3 times equation 2, and I'm going to subtract equation number 3. So I'm using a combination of EROs And that's going to be my new equation 3. This is an ERO combo. It is multiplying that middle row by 3 and then subtracting row 3 from it. So let's take a look at that. So twice equation 2 looks like 2y minus 2z equals -4. Equation 3 is 3y. Whoops, I don't know why I did 3 of them there. So, sorry, 2 of them. This should be a 2. Sorry, this should be a 3. I'm a spaz. I said I was going to do 3 times equation 2, and then I didn't. So this is 3y's minus 3z's is equal to -6. And then 3y plus 5z is equal to 10. And we're going to subtract. And 3y minus 3y is 0 y's. -3z minus -5z is -3 plus 5 is a positive 2z. And -6 minus 10 is equal to -16. And something happened. I flipped a sign here somewhere. Where did I lose it at? I had a -8. I think I have a mistake in here somewhere, but I just want to illustrate this technique. So let's keep going.
Isn't the 5 supposed to be positive? It's 3y plus 5z.
Thank you. There it is right there. That's my mistake. So this, let's clean this up again here. Let's see. That should be a -8z. Thank you. And so my new row 3 is -8z is equal to -16. So that's, good eyes, that's what's going to go right here. -8z is equal to -16. And so I'm now going to rewrite my system. This is x plus 2y plus z is equal to 1. Y minus z is equal to -2. And then what I'm going to do is I'm going to do -1/8 of equation 3 and make it my new equation 3. So that'll give me z is equal to 2. And so what we're going to notice here is we now have one variable solved. Z is equal to 2. So we are done with our elimination. And now switch to back solving. So we're going to take this system and we're going to, oh, come on, don't freeze on me now. We're going to take this system, give my tablet a second, folks, it's a little bit frozen. I'm going too fast, probably for some of you guys too. Come on, you can do it. So what we're going to do here is we're going to substitute into equation 2, the equation just above it. And that's going to tell us that y minus 2, which is z, is equal to -2, or y equals 0. So now we have two variables solved. And we're going to take that information and we're going to go right back up to the first equation. So substituting into equation 1, where y equals 0 and z equals 2, we get x plus 2 times 0 plus 2 is equal to 1, or x plus 2 equals 1, or x equals negative 1. And now we have what's called our solution. It's not an ordered pair. Our solution is what's called an ordered triple, x, y, z, and it is negative 1, 0, 2. And if we take those values and go back to the original equation, let's go back here. Way back up here. And I know that this seemed really long-winded, and it was because I was sort of explaining it as I was going. But this will become faster, and you should get faster at it. And I'll show you other techniques that'll make it faster as we go. There's lots of opportunity to make mistakes here. And I know even obviously I'm not infallible. I've made a few mistakes along the way, just in this example that I had prepared for everybody. But what I'd like you to do is, if you make a mistake and you get down to the end, you should just check your answers. So let's check. In equation number 1, the ordered pairs are, or the ordered triple is negative 1, 0, 2. So x is negative 1, y is 0, z is 2. And equation 1 gives us negative 1 plus 2 times 0 plus 2, which is negative 1 plus 2, which is equal to 1. That one works out. Check. In equation 2, we get negative 1 plus 0 minus 4 times 2, which is 1 minus 8, which is negative 7. Check. And in equation 3, we get 2 times negative 1 plus 0 minus 3 times 2 is negative 2 minus 6 is negative 8. Check. And so negative 1, 0, 2 satisfies all equations simultaneously. So negative 1, 0, 2 is a solution to this system.